panel virtual events. Today's session will be all about statics, not to be confused with statistics, from SSSP tutor Mauricio Mora. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's event will be able to come and watch it. Thank you. So now, at this time, please mute your mics for the best sound experience, otherwise the feedback could interfere with information we will be sharing today. Now, without further ado, here's Mr. Mora.
Hi everyone, give me 1 second to share my screen for the presentation and we'll get started, okay? Okay. Can everybody see it okay? Give up a thumbs up on
it looks perfect.
Okay, perfect. Okay, so one thing, just a fair warning, I do like it when people contribute in the chat and everything, right? So if I ask you to put some emojis down or stuff like that, just be ready and handy. I'm totally fine with participation, okay? So without further ado, my name is Mauricio Mora. I am a tutor at the Student Support Services Program, the SSSP. And I've been a tutor for around 6 years. So you'd be very surprised how many people come up and ask about this particular course, especially in the engineering department, okay? So let's get started. So what is statics? What's the definition? Now, if you were to read it straight out of the book, it says statics is the branch of mechanics that is concerned with the analysis of loads, force and torque or moment acting on physical systems that do not experience on acceleration, but rather are static equilibrium with their environment. Now, that is a very confusing definition, right? So I don't know why the books always make it really complicated, but in simple terms, it just means the study of forces and weights on things that are not moving, that are at rest, okay? So if it's holding still, then we study the forces that are on it. So what are some examples of like things of statics? For one example, are bridges. You don't want the bridge moving from island to island while you're driving on the car, right? So you want that to be static. You want it to be not moving. You want it to be at rest. Another thing, very simple, a table, right? You want it to hold still. You don't want it rolling from kitchen to living room to bedroom, although that would be pretty cool if you could just like eat wherever you want, right? Another thing are stages, right? You do not want a stage, concert stage to move or topple over, which brings up to this next quick video. I do have to warn, viewer discretion is advised. I feel like one of those TV. It is pretty like horrible what you're about to see. So that is one of the reasons why statics is really important. You do not want a stage falling over, especially like that. I do have to tell you, nobody died during this. There were, however, many injured, but it is one of those things that you want to avoid as an engineer, okay? So it is really important that understanding this concept will help you later on, like knowing, okay, the value of this, okay? So what are some materials that use statics? Some materials that use statics are physics. You use a lot of the techniques that you use in physics, you use them here in statics. Another thing, mechanical engineering courses, if I'm not mistaken, they also have to work with statics and mechanics of materials. So that involves statics. And my personal favorite, because I studied this, so I am a little biased. I am a civil engineer at heart. So it does repeat throughout the your college life, okay? You see it again in civil engineering fundamentals, structural analysis, dynamics, mechanics of materials, okay? It's one of those things that you need to have a good understanding of so that you can work on it professionally, okay? So everybody get ready with your screaming emojis, okay? Because we have some horrible things that we're gonna be working with, okay? So behind these three doors are the stuff of nightmares, the stuff that students scream as soon as they see them. They just want to like give up right away, okay? So are you ready with the first door? The first door behind the door number one is trig. We're gonna be working with trig, okay? Hypotenuse, the adjacent, the opposite, the angle, sine, cosine, tangent, and the Pythagorean theorem to be specific, okay? It's horrible. The next thing, weights and forces, okay? That's another horrible thing that we're gonna be working with. And then finally, we're gonna be working with 2D graphs, okay? So if you have a lot of experience with these three things, maybe it's not that bad, but keep in mind, we are going to be working mainly with these three, okay? So what is it that we're trying to find? In this particular lesson, it deals with like the initial stuff of statics, okay? So in the very beginning of statics, they try to teach you certain tools and techniques that deal with tension and forces, okay? So if you have these two, let's call them ropes. You have rope number one and rope number two, and you got like a little hook right there, right? And each are exerting a force, right? You're pulling on it, right? This longer one just represents that you're pulling on it harder, okay? The shorter one, it's not as much as the other one. So what we're gonna do is we're gonna move one of that force and we're gonna move it and keep moving it until it reaches the tippy top, okay? As soon as it reaches that top, we connect from origin to edge, okay? And that right there is called the magnitude, okay? The magnitude is basically the sum of the forces in total that that you will be working with, okay? So like if someone's pulling on that thing, then you have a total magnitude of force going in that direction. So another thing that you look for is the direction of it, okay? Where is it getting pulled the most? Okay. Now, one thing to note is that I want you to notice that if we were to take this and break this apart into a triangle, you could work with it as a right triangle. So if we come back over if this next slide, we have the resultant force, right? Now, this is the concept. This is a very easy concept to grasp, okay? So let's say you have two forces that are dealing with each other, right? And we break them up. Now the first, yes, Fr is equal to magnitude. The resultant force and magnitude are basically the same thing. So if you have a small force of X and another force of going in that direction, in the X direction, when you add them up, that will give you a big force of X in that direction, in the X direction. Now let's do it for the Y. If you have that force in the Y going up and another force going up in the Y, and you add them together, that will give you a big force in the Y, okay? So in simple terms, let's try to remember our Pythagorean theorem, okay? A squared plus B squared is equal to C squared. This is the main concept that we're gonna be working with so that we get the magnitude. Now, one way to simplify this is you can square root both sides, and that square and the square root cancel each other out because they are opposites. So C is equal to the square root of A squared plus B squared. Now, let's replace things. Usually, this is an A, this is a B, and your C will always be the hypotenuse, right? So another way to rewrite this is that your FR is equal to the square root of your fx squared plus your total of Fy squared. And that's it. That's how you get your magnitude, the same way you get your Pythagorean theorem. Okay? So let's move on to the next slide. This is a typical problem that you see in statics. It's usually the stuff that you see at the early stages of it. Okay? So what we're going to do is we're going to break these up into two separate right triangles. Okay? Working with right triangles makes your life a lot easier when it comes to these kinds of classes. Okay, so you have a right triangle there and a right triangle there, the red and the blue. I was nice enough to separate them for you. Okay, so this red triangle represents the 30 degrees one, right? You got 30 degrees, and the 45 and the 45. Okay, so first, I'm going to try to break this up into three simple steps. First, what are we looking for? We're going to be looking first for the x direction of the forces. Okay? So the ones that are horizontal. For example, this one. And let's change it to, whoops. Let's change it to blue. And this one. Okay? So then, now that we know which ones we're looking for, now we need to know the direction of the forces. Okay, let's start with just the red. So the direction of this force is going to get to this arrow. The arrow is very important. To get to that arrow, you need to go up, then to the right. Because it's going to the right that makes it a positive. Going to the left makes it negative. Okay? So positive, always start off with the weight itself, 250. And this is where we're going to use our sine, cosine, and tangent. Now, if you need a little refresher, it's some people remember it as SOHCAHTOA. Other people remember it with one of those rhymes, I guess, or to memorize it. I think it was some old hippie caught another hippie tripping on drugs. I mean acid. Yeah. So that's one way to remember it. However you guys remember it the best, I recommend that. Okay. So we're dealing with, we don't want to deal with tangent as of yet. That's going to be at the very end. Okay. So just focus on sine and cosine. So Patricia asks, positive is equal to the right direction, negative is equal to the left direction, just like a graph, correct? Yes, that is absolutely correct. Okay. As well as going up is positive and going down is negative, which is going to come up later. Okay. So thank you for asking. Okay, so according to this angle, where is the side that you're looking for? So if this is the side that you're looking for, it is opposite to that angle. So if it's opposite, you use sine. Very good, Diana. So sine of 30. And that's it for the first one. Now let's work with the blue one. Again, first, let's look at the direction. So the direction went to the right and down because it is going to the right and we're looking for this side first. It is positive. Okay, always start off with the same weight, same force. Now we're going to use sine or cosine. Okay, because this angle is touching the side that we're looking for, it is adjacent, therefore you use cosine. Cosine 45. Okay, so all you have to do is 250 sine 30 on your calculator plus 375 cosine 45, and that will give you a total of 390.17 pounds. Okay, that's simple. Now we're going to do the y direction. Okay, for the y direction, let's start off with the red again. Again, first, what are we looking for? The y direction, up and down. So it is going up to the right, so you know this is going to be positive. Start off with the weight itself, and then this angle is touching this side, so therefore if it's touching, it's adjacent, therefore it is cosine. Okay, now the next one. Now this is where it goes a little bit different. It's going to the right and down because it is going down and we are looking for the vertical direction. It is negative. Start with the weights itself, so 375. This angle is opposite to the side that we're looking for, so sine of 45. Okay, I know I kind of smushed it there together, but here, let me write it out again. So you have a positive 250 cosine 30 minus 375 sine 45. And that's what you're going to put in your calculator. Okay. Is everybody okay up to this point? Do you understand why this 375 is negative? Because I see Tammy going, oh no. Okay, perfect. All right. So it is going down, so therefore it is negative. Okay, so the answer here, when you add them up, gives you negative 48.66 pounds. All right, so let's move on. Now that we hold on to these two values, the fx and the fy, now we're going to work with our resultant force, okay? That involves you plotting these 2 points. Again, because it's in the x direction, this will be for your x-axis. Because the second one is in the y direction, it's going to be in the y direction, okay? So let's count it off. Ready? 1, 2, 3, 390. Okay, I wasn't going to count to 390 by ones. I'm not crazy. I only teach crazy stuff. And then the negative 48, so that means you're going down in the y direction up to negative 48.66. Okay, so that more or less looks like this. You're gonna have a little dot right there, and I'm gonna try my straightest line as possible, but keep in mind I'm not the artist. Okay, there we go. So more or less, okay? So if I were to connect this up, you have your right triangle, okay? We know this side is 390.17. We know this side is negative 48.66, right? So now it's just a matter of using your Pythagorean theorem to work this up. Now remember your Pythagorean theorem. Why don't we connect from the y-axis side? Oh, if you'd like, we could also do that. It's up to you. I personally just always connect it through the y, but if you were to do that, then yes, you can totally do that over here. Usually the next step involves looking for the direction, and you always want the direction that is connected to the x-axis, okay? So I highly encourage people to just connect it with using the x-axis and then connect it up to the y, okay? So let me erase those dots so that we don't get confused later on. All right, there we go. And we are done. Okay, so back to this. So you know that c squared is equal to a squared plus b squared. That is your Pythagorean theorem, right? So like I mentioned earlier, right, you find the square root of both sides and you can figure out like that, right? Now this is what we're looking for. So your x direction squared plus your y direction squared, and then that will give you a resultant force or the magnitude. Remember, this is also the magnitude. So it would be the 390.17, I'm going to put that in parentheses, squared, plus your parentheses negative 48.66 squared. Find the square root of that, and that will give you a total of 393 pounds. So this hypotenuse is 393 pounds. Okay, so let's hold on to that. Now we know this is 393. Okay, so now we're gonna look for the direction, the theta, okay, the angle. How much did I have to travel in a circle to get this, okay? So this is your theta right here. If I were to connect it again up, that's your right triangle. We know that this is negative 48.66, and then this is 390.17. Okay. Diana, I thought you always drop to the y-axis because of how the angle is measured. Yes, and that's exactly what we're doing here. So there's two different angles that usually they ask in books. Okay, so we're gonna first start off with this angle, and then I'll teach you the other angle, okay, as we move along. So for tangent, it is the same thing as opposite over adjacent, right? So to figure out your angle, you do the opposite of tangent, which is the arctangent, right? That tangent to the power of -1, that's your arctangent. So of y over x, so another way to write this out is your fy over fx. Now, one thing that I need to mention is always use positive values for the direction. The reason why is because the calculator, when you insert something like negative 390.17 over 48.66, that is the same thing as the positive 390.17 over negative 48.66. So the calculator gets confused. Sometimes it'll just give you a weird answer. Sometimes it'll give you a correct answer, but maybe not the answer that you are looking for, okay? So it's always important to work with positive values so that you just end up with this angle itself, the one that connects to that triangle, okay? So your Fy is 48.66 over your Fx, which is Fx 390.17. And that's we're gonna look for the arctangent of that. Okay, and I already did it for you. It is 7.11 degrees clockwise the x-axis, because we start from the x-axis and then we move down to that line. So the other version that they might ask for is counter. Yes, perfect, Patricia, you got it right. It is a negative angle, okay? So you usually in mathematics and physics and engineering courses, counterclockwise is positive, and then clockwise is negative, okay? So 7.11 degrees clockwise, the x-axis, okay? So then usually they ask for the counterclockwise. They want this angle instead, where you start at the x-axis, you work all the way around till you reach that point. Now, if you remember, a circle has a total of 360 degrees, okay? So, and we know that this angle right here is equal to 7.11. So if we know the full circle is 360 and the chunk that we want to cut out is 7.11, just subtract the two. And that will give you 352.89 degrees counterclockwise the x-axis, just the opposite direction. That is usually the most common way they ask these types of problems, okay? So I found it that it's easier to, if you know which angle you got, it's easier to either subtract 360, or sometimes you can even subtract 180 because you have, let's say, an angle right here, and you figured out this angle. Then if you know that half a circle is 180 degrees, then this minus that angle, okay? So that's it. That's basically the idea. That's the concept, okay? All right. So now I thought it'd be a fun, cool little way to do this one all together, okay? So if you know the answer, just type it out in the chat or just unmute your button. It's okay. I'm gonna work this along with you guys, so don't freak out too much if you guys don't know. It's so many triangles, exactly. So let's work this out. Now, another way that they teach you, rather than angles, they have this little triangle that's called a similar triangle. So it's a 5, 12, 13 triangle, okay? So I'm gonna show you, I'm gonna work this one out by myself so that you guys can see the concept, how that's done. But you guys will help me with the 60-degree and the 45-degree. So I'm gonna do a triangle like this, okay? So let's just work it out up here. So that gives me a 650 Newton, and it's going in that direction. Remember, the direction is really important, okay? Now, the only thing that we have is the 5, 12, 13, so just hold on to that, okay? And then the next triangle, let's do it blue. So you have that going down and then this way. Okay, so I'm going to try my best to make the nicest triangle as possible. So I went up, down, this way. And this is that direction. And we know this is 60 degrees. Okay, so hold on to that. And the hypotenuse is 800 newtons. Okay. Finally, let's do a green one. So I always try to grab the triangle along with the angle, okay? So that's why I'm grabbing it, like for example, this triangle, I'm grabbing the side of the 45. If you were to grab this other triangle, first you need to figure out this angle, okay? So since I already gave us that triangle, I'm gonna work with that, okay? So let's go back to green. It is horizontal, down, and this way. And we know that this angle right here is 45 degrees, and the hypotenuse is 600, and the direction is going that way. Okay. So for the red one, let's first, well, for all of these, first let's look for the X direction, the horizontal direction. Okay. Yes, Patricia, X is going to be positive and the Y is going to be negative. Why is that? Because we are going to the right and down. So to the right is positive, to the down is negative. Very good. So for the horizontal direction, it's going to be a positive. Again, start off with the weight that you know, which is 650. Now this is where you put your angle, right? Usually it would be the sine or cosine. In this case, they gave us a similar triangle, which is like this. The 13, the 12, and the 5. Okay, whoops. So you are looking for the horizontal direction, so you grab the 12 because that's horizontal and always put it under the hypotenuse. And that's it. That's it for that triangle. Now let's start off with the blue one. So does that make sense why we grab the 12? Because it is the X direction, okay? Now for this one, we're gonna go to the right and up. So what does the people say? We're looking for the horizontal direction. Is that positive or is that negative? Positive, thank you very much. So positive, copy down the 800, and this is where we're gonna pick sine or cosine. Now, if you need a little refresher, I'll write it down again. Sine theta is for when you are looking for the opposite, and cosine theta is the one that you're looking for the adjacent. Okay, so to this angle, the 60 degrees, is it touching the line or not touching it? It's touching, right? So do we use cosine or sine? What does the people say? Cosine 60. Very good. Very, very, very good. 3. Okay, so for the next one. Now we're doing with the green one, okay? Now it's going up to the left. It's going to the left, so is that positive or negative? Negative, very good. So because that is negative, we're going to put down negative. Whoops. Very good, negative. Thank you, Tammy. Again, we write down the 600. We just copy down that. And then here we go. Look at the angle. The angle is 45 and the side that we're looking for is opposite to it. So which one do you use, sine or cosine? So what does the people say, sine or cosine? We're looking opposite to this 45 degrees. Very good, sine of 45. I already did the math for you. 650, 12 over 13, plus 800 cosine 60, minus 600 sine 45 will give you a total of, whoops. I wrote it down. X direction, 574.74 newtons. And this is in the X direction. So hold on to that. Now we're going to do the vertical direction, okay? So let me switch my color. So when we add it up all together, it's the magnitude on the thing. It's a part of the magnitude. So remember, what we're doing is we're trying to figure out a triangle, right? If we know that this is 574.74, and we know the y later on, which we're going to get, then we can figure out the magnitude, which is the what's it called? The hypotenuse, okay? So yes, when you add it all together, it's going to give you the magnitude of the thing. So let's keep going. So the vertical direction. I'm going to try to make as much room as possible. So now let's start off with the red again. I'll do this one. So it is going down, so you know it is negative. It went down, so it's negative. You copy the weight. Now this one, you go to your similar triangle and look at the vertical one. So the vertical one is the 5. So 5 over hypotenuse, and that's it. Okay. Now let's work with the blue. So first, positive or negative, it is going to the right and up. If it's going up, is it positive or negative? What does the people say? Positive, very good. So it is positive because, Patricia, you got that part down. Yes, Tammy. And then positive, you copy it down, the 800, exactly how it is. A good rule of thumb is, check this out. If you, for the horizontal, you worked with cosine. For the vertical direction, you're going to work with the opposite, which is sine. Just to double check, let's say that's true. This 60 degrees is opposite to the side that we are looking for. So therefore, if it's opposite, you use sine. Okay? And you're going to see the exact same thing with the next one. So it went up, to the left. So for the y, that gives you positive. So positive, the 600, you copy it down. Here I use sine, so now I'm going to use cosine. Let's double check if that's true. So let me make that a little bit clearer and nicer. Okay. So we are looking for this side. This side is touching the 45 degrees, so therefore it is adjacent, and you use cosine. Okay, so you see how they're opposites. Cosine turn into sine, sine turn into cosine. You add these up, and your Fy, your total, will equal to 867.08. So that means that you have two positive values. So let's see what that looks like. If I were to graph this out, positive and positive, right? So positive 500, positive 867, 574.74, and 867.08. There's that dot. We connect the dots. Now you have your right triangle. Okay, so this is 867.08 and 574.74. A squared plus b squared is equal to c squared. So you can just work it straight up from the Pythagorean theorem. So 574.74 squared plus 867.08 squared is equal to, instead of c squared, I'm just going to write down your resultant force squared, right? Find the square root on both sides. That cancels out with that because they're opposites, and opposites cancel each other out. So find the square root of 574.74 squared plus the 867.08 squared, and that will give you a total of 1040.81 minutes. Okay, and that's it. That's it for the resultant force. You got your answer. That's the magnitude. In physics, instead of weights, sometimes they use like velocities or accelerations, okay? But it's exactly the same concept. You add up the ones in the horizontal direction, and then you add up the ones in the vertical direction. You put them together using Pythagorean theorem, and you get your magnitude. You get your resultant force, okay? So the last thing that you need to get is, and let's just get the angle in the counterclockwise direction, okay? So we are looking for this angle. So again, you're going to use tangent, because on tangent is equal to the opposite over adjacent, or your Fy over Fx. So tangent theta is equal to your y, which is 867.08 over 574.74. Arctangent both sides to get your answer, and you get an angle of 56.41 degrees. And that is it. Now, did I lose anybody? Does everybody have like a good idea where this is coming from? Why would we want the angle? The angle is really important so that you know exactly which direction the force is getting mostly pulled on, okay? So in this case, we have all of these ropes, right? Something's pulling this rope on the, here, let me switch to the laser point. Something is pulling this rope at 600 newtons. Newtons is just another way to say weight or like pounds or something, okay? It's just a different metric. This way 800 newtons and this way 650 newtons. So if everything is getting pulled, which way is it really getting pulled the most? So what we learned from the direction is that in reality, this, what's it called? Like this hook is getting really pulled at this direction at a total of 1040.81 and a direction of 56.41. Now it's really important to get the angle, because if you want to cancel out that angle, if you want to make sure that it doesn't get pulled down anymore, you need a force going the opposite direction at 1040.81. This is where things like when they're setting up a stage, they add these like huge cement blocks, right? Or you might see them like in the side of like a highway, right? That they just put cement blocks that like connect each other, right? So when they add this cement block over here, they need to know that it needs to withstand at least 1040.81 newtons to be able to keep this from being pulled that direction. That's the general idea. That way, all of these, when all these forces get add up, you end up with 0. That's why we want the angle. If you know the angle, you know which direction exactly to cancel it out with the other ones. Yeah, pretty cool, huh? So back to that video. If you remember that video, the wind is blowing really, really hard, right? You have wind that is pushing against that stage, right? And this wind is going, I don't know, really fast, like 60 miles per hour, let's say, just for argument's sake. If we know how much force is being acted on that stage, then to cancel it out, you would have needed a rope or something to interact with that stage so that they cancel out and it wouldn't have buckled and it wouldn't have fallen over. It seems like very important math to know. Well, yeah, especially if you are in engineering, and any kind of engineering. It could be mechanical engineering, civil engineering. Everything has to, you know, in of itself, if you build something, it's going to weigh something. If you're making something, you got to make sure how to counteract those forces. If it's vibrating, right, then you need to know how to use these tools so that they won't break apart when you pull it together. So for another example is like earthquakes. When here in El Paso, we are very close to a rift, basically. And that rift tells us that in the future, there might be an earthquake. So every building in El Paso has to be ready for an earthquake. So that force needs to be canceled out with something. And this is where statics comes in. You need to cancel out a potential earthquake, so you use statics to cancel it out. So it can still maintain its, and it doesn't topple over and stuff, okay? And that's it. So in these last 5 minutes, I'm gonna give you all a little quiz. Do not freak out too much. It's very simple. Everybody get ready with your emojis, okay? Here we go, because instead of multiple choice, it's just emojis. So what is statics? So the study of forces when an object is in movement, the study of forces when an object is at rest, not moving, the study of how radiostatic happens, or was it that nobody told me there was going to be a quiz? Very good, Patricia. Very good, Sam. Yes, yes, yes. Okay, very good. Tammy, you got it. You got it. Elizabeth, yeah, I should have warned you in the beginning, but if I tell people, they usually like leave. So very good. And then finally, last question. What is statistics? No idea. I came to study about statics. The same as statics, but with a tis in between. If you don't see it, it's right there. Deals with probability. Which one? What's the answer? All right, Patricia, Gemma, anybody else? I know what you're all thinking. I know what you're all thinking. But no, you were all wrong. The answer is that one, all of the above. All right, with that concludes my presentation. Are there any questions? That is out there.
Mauricio, that's so not fair. Oh, I think you got us good. Is there any questions at this time for Mr. Moore? Oh, I really enjoyed your presentation. I feel way smarter than I did when I started. So thank you, Mauricio.
No
I would
problem.
like to give a special thank you to our Student Support Services Program, SSSP. If you need any kind of assistance, especially with statics, they have the hookup with Mauricio. So please go check them out when you get a chance. The more information for you is in the chat. As well, I'm posting the Tejano Passport code in the chat if you're participating. And then I would also like to invite you to this afternoon's Tejano virtual event. So right now we had all about statics, not to be confused with statistics, which, oh, that was such a good time. Okay, and then next up at 3 o'clock, for Math 1314, we're gonna have properties of logarithms, exponential and logarithmic equations. And then for Math 1324, we'll be having basic matrix operations and inverses. Then, if you join us next week in the same room, we're going to have a wonderful presentation from Makerspace. And then for Happy Math Hour, we're going to be going over linear and nonlinear systems, as well as going over a review for exam 3. So thank you very much for coming today. I hope y'all have a wonderful weekend and happy April Fools.
Thank you all.